So we're now going to do the surface area and volume of cylinders. All right, let's review first. The area of a circle is pi r squared. Circumference is pi times d, or 2 pi r. One way to remember and keep them separate is that area is always measured in square centimeters, square inches, square units. So that's why you have to have the r squared. So the r squared is with the area. You don't have any squared terms with circumference, either pi times d or 2 pi r. Okay, so let's talk about the net. To find the surface area, we need a net, because really the surface area is just the area of the net. The net looks like this. Now it's not going to look like, let me erase this a little bit. If you have a real thin column and a circle on top, that's not going to be the net, because these guys, this really is not going to, it's going to be a big hole on the side. You need it to be longer. Okay, so that would be a net, but this, of course, is not a net. You could also have it, you could have it like this on the side here. That's fine too. That's a net of a cylinder as well. But when it's too short, too less of a part in here, that's not going to be a net, and they're on right next to each other, it won't be a net. So just to be clear about that. Okay, so the surface area is going to be the two circles plus a rectangle. All right. Well, the two circles are the two bases. If you think about this rectangle we know is length, the area of the rectangle is length times width. But this length, if you think about it, this area, this part right in here, I'll try to use black here, this part comes from the circumference of the circle. So instead of this being the length, we can think of this as being the circumference of the circle. And this part right here, you can get a red pen, this is really the height of the prism. So instead of being the width or the length, whatever, it's really the height. And if you want to use capital H, you can for the height. All right, so now let's break it down some more. B plus B is 2b. Circumference, remember, is pi times d, so I'm just going to use pi times d, and times the height. Well, let's think about it some more. The area of the base, that's what the B stands for. Well, the area of a circle, which is the base, is pi r squared. So 2 pi r squareds I have. Plus, well, since I've used r here, it might be nice to use the r form of the circumference here, the radius. So it's 2 pi r times h. And a way to think about this is if you think about going to McDonald's and you order pies. Now, I know that pies are not squared, but just pretend and you can think, okay, 2 pies are squared and 2 pies are hot, because they're definitely hot when you go to McDonald's. So 2 pies are squared and 2 pies are hot. Okay, if you kind of remember that, that'll help you remember the surface area for a cylinder. Okay, let's go through some examples. All right, so here I have a cylinder, and the height is 10, the diameter is 12. Well, you know right away you need the radius. Okay, so right away, go ahead and make yourself a little note. Okay, r is 6. If the diameter is 12, the radius is 6. Write down your formula. Plug in all your numbers. 2 pi 6 squared plus 2 pi 6 times 10. You break it down, that's going to be 72 pi and 120. Don't do the 3.14. Don't substitute that in for pi just yet. Go ahead and get it all down to 1 pi term. See, here I can think about this 72 pi as being 72a plus 120 times a. A is just pi. So here you see, oh, that's like terms. I can combine them. So 192, instead of a, of course, it's pi. Now, when you leave it in this form, this is the exact answer. Sometimes they'll say, give us the exact answer. And that means they want you to keep pi, pi. Sometimes they'll say, give us an approximate. When it's an approximate, that's when you substitute 3.14 in for pi, or the 22 over 7. Here I just multiplied 192 times 3.14, and I got that answer. And that's an approximate answer. Okay? You can think that's 3, it's about 3, so it would be about 200 times 3, which is about 600, so that's about right. Okay, now we think about volume. Remember, the cylinder is a prism, okay? A prism is, the bases are congruent and parallel, which we have 2 circles that are parallel and congruent, and it goes straight up and down, right? So that's what, so a cylinder is a type of prism. All the formulas for all the volumes of all the prisms are area of the base times the height. And the reason that is because if you think of a cylinder, we can just think of it right here, erase this one. And if you think of a cylinder and you think about filling it, well, you could put like a lid here, a lid there, a lid there. You keep on stacking it with lids, you get as many lids as you have the height for. So it's the area of that lid times however high it is. And that's exactly why it's the area of the base times the height. And the area of the base is pi r squared times the height. So that's your basic formula. All right, let's go ahead and find the volume for the formula for the cylinder number 1. We write down our formula. Go ahead and make it pi r squared times h and plug it in. Pi 6 squared times 10, which is 360 pi. All right, now let's try an interesting problem. I think you'll find this problem kind of cool. Okay, if you take an 8.5 piece of paper, which I'll do right here. Take an 8.5 piece of paper. All right, 8.5 by 11, I mean. piece of paper, which way makes the cylinder with the most volume. In other words, if I could turn it this way, would I be able to put more candies in it this way? Or if I did it this way and made my cylinder a little bit shorter, could I fit more candies in it this way? Important question to ask. Okay, well think about this now. If I did it the long way first, my bases would be on the top, so they would be little circles, very small circles. Okay? But remember, this 8.5 is not the diameter. That's the circumference. So go ahead and write an equation. Circumference, which equals 8.5, is equal to pi times d. So to find diameter, I've got to divide through by pi, and I got 2.7. Then to find the radius, I've got to cut that in half, so that's 1.35. So my radius here is really 1.35. I did the same thing with this one. 11 was my circumference, so I found d, and then I divided it by 2. So my radius here is 1.75. All right? So of course you know that the radius for the one, if I made it like this, would be smaller than the radius, because a circle is a lot smaller than the circle would be formed if I put the radius, if I put the cylinder like this, the paper like this. Okay, so let's go ahead and solve for the volume. We'll talk about surface area in a minute. Okay, area of the base times the height, pi r squared h, so I plug in 1.35, and this is a 2 here, squared. I'm squaring it. When I square it, multiply it by 11, I got 20 pi's, basically. If I did it here, I got 1.75 squared times 8.5. When I squared it and multiplied it, I got 26 pi. So who has the most volume? Right, the shorter guy has more volume. All right? Now, think about the surface area. Would the surface area be the same? Well, what part would be the same? The rectangle part, the lateral part, the sides would definitely be the same area, because I'm just making it in different positions. But with these two circles, with the area of these two circles that would be formed, would they be the same? And the answer would be no. And we can talk about that in class, what the difference would be. But it's an interesting problem, and one that, that is good to think about. All right. I just wanted to do a couple more problems just so you get the idea of how to do it, and then we'll do more in class. These are numbered wrong. These should be, I think, 4 and 5. Okay. So, for number 4, find the area of the label of a soup can with a radius of 3 and a height of 6 inches. Okay, so sometimes we're not finding the surface area of the whole thing. Sometimes they just want you to find the surface area of part of it. All right, so I went ahead and drew my little cylinder and labeled it. And all you need then is just the label, not the base. So all you need, if you write your formula down for surface area, you really don't need the base part. So you can scratch it out. All you need is this. Well, then you just plug the numbers in. 2 pi times 3 times 6. And you get 36 pi. If they want the approximate one, you just multiply this by 3.14. Okay, number 5. Do these have the same surface area, these two cylinders? Find the volume for both. Okay? So this one, again, I right away, when they give me the diameter, I put down the radius right away. So I have a, don't get confused with that. I write down my formula, plug the numbers in accordingly, and I got this to be 90 pi. When I went over here and did the same thing, I got 48 pi. So clearly, again, we see that the surface area for the one that's flatter and rounder is more than the one that's skinnier. Okay, this is a little bit different of a problem, though, because I went ahead and gave you the diameter, and the other one I gave you the circumference. Okay, then to find the volume. All right, area of the base times the height, pi r squared, 5 squared times 4, that's be 100 pi is the volume of this one. Oh, that was the surface area, I'm sorry. Surface area, it still is going to be more. Here the volume is 100 pi, and this volume, the radius is 2, so 2 squared times 10 is going to be 40 pi. So you see how much more that will hold than this one. All right, we'll work out a lot more problems in class. Okay, that's it.